before, people always had trouble setting up the angle. Like, where do I put the angle? There are two types of angles they can give you. They can give you an angle of elevation and an angle of depression. Here's the definition of them, and then we're going to draw it out here. An angle of elevation is the angle through which the eye moves up from the horizontal to something above. So it's like if you're standing on the ground and you're looking up at a building, the angle of elevation is that angle of you looking up to the top of the building. So angle of elevation comes from the ground up to what you're looking at. So right here would be your angle of elevation. The other type of angle we have is the angle of depression. Maybe that's just your overall feeling about precalculus altogether, right? That's the problem when you retake my classes. You can hear my jokes more. No, I think I did that for something in
calculus too.
In calculus, and
Probably just
Cora was the only one that laughed. What was it? Oh, anti-differentiation. I said you might all be anti-differentiation, like. But yeah, Cora got a good kick out of that one. Angle of depression means it comes from the top. So if you're standing on the top of a building looking down, the angle comes from the horizontal at the top of the building. So it says the angle through which the eye moves down from the horizontal to something below. So if I draw the same lovely building that I drew up there, you have to now think about the horizontal coming from up here. That's my dotted line. Which means the angle of depression is from the top looking down. But really tricky, it's this angle right here, not the one over here. So that is your angle of depression.
I thought you said there was like a secret picture of the notes or something.
Oh, we're not there yet, dear. You'll know. It's not really very secret.
Oh, it's not there.
Yeah, they just did it last hour.
Oh.
It's not secret at all. It's mostly there to scare you, but you're anticipating it now, so. Which means you could draw a triangle like this. We'll talk about in a minute when we do one of these what are some other options, because we can use our properties of angles to figure out some other stuff here. But angle depression comes from the top, horizontal angle of elevation comes from the bottom. The big idea is make sure you draw your picture correctly, and then you just set up the trig function. A lot easier than some of the things that we've done in this chapter. So let's just look at some awesome. Oh, God!
Is that what it was?
Yeah. Oh, Mr. Griswold.
Oh, he's a silly little fella. Was that the secret?
That was the secret.
That's a terrible secret. It's like the elephant in the room.
An amateur radio operator builds a 75-foot tower for an antenna. I'm aware this is not a very good tower. Find the angle of elevation to the top of the tower at a point on level ground 50 feet from the base.
Is this an Egyptian radio tower?
It is an Egyptian. Kind of looks like Washington Monument Egyptian radio tower, we decided. You know, it's a tower, whatever. Where do I put the 75 feet?
On the left, going up?
Yeah, it's a 75-foot tower. So this lovely tower here is 75 feet. I want the angle of elevation to the top of the tower at a point on level ground 50 feet from the base. So I'm going to measure 50 feet this way. So that's pretty careful.
What's the angle of depression and elevation in this?
No, yes. Depending on how you, yes. But here's the problem. A lot of people with the angle of depression put it up here, like this side instead of this side, and then they get it wrong. But yes, you're right, because, so, he's saying this is our angle of elevation, and Chase is pointing out that if we drew in the horizontal this way, he's saying this angle and this angle are the same. Do you agree with that statement?
Chase is a student.
Because those are alternate interior angles. Do you agree with that? Remember those from geometry?
Anyways.
They're contradictory
It's true.
angles.
Not contradictory. Not even complementary. They're congruent angles. They're alternate interior angles. Because this is the lovely transversal cutting through between them. Yes. So, you're going to see that when we write our angle of depression, we can always reflect it down here and set up the same thing. But, since this one is angle of elevation, I'm just going to keep it there. And And then now this is where you say, which trig function could I set up to solve for theta if I know this side and this side?
Tangent.
Because I can say tangent of theta equals 75 over 50. What do I do on my calculator to solve for theta? No. You have to do inverse tangent, right? If you're looking for theta, the only way to get rid of tangent is to do inverse tangent of 75 over 50. And usually with story problems, we do degrees just because our answers, you know, it's nice to get a nice degree answer.
Hey, could you please verify square root of
You could. That would find this side, but that wouldn't find the angle that we're looking for. You see what I'm saying?
Oh, yeah.
Like, we're trying to find the angle there. Anybody else need a calculator?
Inverse tangent.
Put it in degree mode. Inverse tangent, 75 divided by 50. And I get that that angle of the tower is like 56.31 degrees.
Oh, wait, what is it? So right in?
If you draw the picture right, it's not very hard, right? Let's do another one. That's just a messy. I almost wrote a 1 first. It should be 3-1. Very similar to what we did on chapter 4 test part 1, only on chapter 4 test part 1, for the most part, I was asking for the sides, and they gave the angle. So we can go the other way now.
Angle of depression.
The angle of depression from the top of the Smoketown Lighthouse, 120 feet above the surface of the water, to a buoy is 10 degrees. How far is the buoy from the lighthouse?
Oh my.
So the tower is 120 feet.
The tower is 120 feet. So if I'm measuring the angle of depression, it's coming from the top, measuring down. So the angle of depression to this buoy way out here. Here's my buoy. Is 10 degrees. So really important that you label that 10 the right spot. So you have two options. One, actually you really have three options. One option is we could just label the 10 degrees up here. That is the angle of depression. The other option, which Chase so nicely pointed out to us already, is that this is also going to be 10 degrees because of those alternate interior angles. So it doesn't matter which way you do that. Some people like to point out, well, if this is 10 degrees, do I know what this angle is here?
Yep.
It would be
Oh,
80,
80.
right? Because this would be a right angle. Yes? Yes? So you could also use this as 80 degrees. All of those are appropriate ways of solving this problem. But the big question is, what am I actually looking for?
Angle of depression.
No, they gave me the angle of depression. It was 10.
Oh,
The distance from the buoy to the lighthouse. So that would be either this distance down here, which would be the same as this distance up here. Yes? Doesn't matter. What if I call this x? Would this also be 120 feet over here?
Okay.
Yes.
Okay.
Yes. Like these are the same triangles. Do you agree with that? Like they're just moved around? Yes. So it doesn't matter which one you like to work with. Some people hate working with this one, so they always flip it down here. I don't care. You should get the same answer. If we set up this one, would I still use my good buddy tangent here?
Yep.
I would say the tangent of 10 degrees equals 120 over x. Or if you use this one down here and you call this y, you would say the tangent of 10 degrees equals 120 over y. Hey, wait, isn't that the same question? That's the same problem.
Can I call it X on the bottom?
Yeah, you call whatever you want. How do I solve that when x is on the bottom or y is on the bottom? No. Yeah. We don't use inverse because we're not solving for the angle. We know the angle. But we could multiply the x over, and then could I divide the tangent over, so I'd get like 120 divided by tangent of 10 degrees.
Whoa.
What'd you get?
680.55.
Yes, that's right. Algebra? Right, I multiply by x, so that cancels this out. Then I divide it by a tangent of 10. And here's a little trick. Every time the x is on the bottom, you'll always end up with the number divided by tangent. Always.
Reasons?
Because you multiply the x over and you divide the other thing over.
I don't think it's right.
Are you in degrees or radians? I don't think 0.2 radians is the same as 680 either. Try it again. 120 times tangent of 10. Divided by tangent of 10.
Oh,
So that buoy is 680.55 feet away. That's not so bad, right? Negative. Let's do another one.
that was cute.
This is about as difficult as it gets, okay? I think, which isn't very difficult. An observer in a lighthouse, look at the same lighthouse,
Oh my gosh.
350 feet above the sea level, maybe not the same lighthouse, observes two ships. Look at my lovely ships I got here. Two ships directly offshore.
It's like a paddle boat.
The angles of depression to the ships are 4 degrees and 6.5 degrees. How far apart are the ships?
1.65.
That's the question. So, can I, angles of depression, draw this in? Sure. And then I'm going to draw in to this ship
And make sure you put 350 feet.
and this ship. This is 350 feet. So first of all, can I find how far apart the boats are right away? No. Because I can't make a triangle to figure this part out, right? Like if you draw in this distance, that's not a right triangle. That's not going to be good. We don't want to do that yet. But what I can do is can I find how far apart this ship is from the lighthouse? And find how far apart this ship is from the lighthouse? And then what could I do? Subtract those, and that would find the distance in between. So the problem with this is it can get a little messy to look at. So feel free to draw two separate pictures if you need to, but let's see if we can make some sense of this. I want to know which one's the 4 degrees and which one is the 6.5 degrees. This one's angle of depression would just be this part. Do you agree with that? But this one, wouldn't it be from here all the way down? So which ship has the bigger degree?
Closer one.
The one that's closer is going to have a larger angle of depression. So this one is the 6.5 because it's this whole distance, and this one is the 4 degrees. It really doesn't matter which one you labeled that way because if you just found one as a 4 degree and one as a 6.5 and subtracted them, you'd get the right answer, right? So, just in case you like your pictures wrong. So I'm going to change colors here. If I do this one, the closer one, and I draw this up,
I draw over the lighthouse.
draw it over the lighthouse, that's fine too. Notice my angle looks terrible. That's definitely way bigger than 6.5, right?
Yeah.
So that's okay. This would be 350 feet, yes? So could I say this distance, I'm going to call that x, just like before, tangent is our good buddy here. Tangent of 6.5 degrees equals 350 over x.
These boats pretty far out.
They are pretty far out. And I could do the same thing for the far boat. It's going to be this big giant triangle. Do you see that? With 4 degrees. This is still 350. But now I'm finding this whole distance here. I'm going to call that y. And I'm just going to say the tangent of 4 degrees equals 350 over y. Pretty far out for these little tiny rowboats, I would think, but I got x to be 3,071.91 feet and y to be 5,005.23 feet. syntax error.
Now you messed up.
So if I take y minus x, I get 1,933.32 feet apart.
Oh, yeah.
Not so bad, right? The big thing is drawing your picture. Some of the problems they'll give you a picture. Sometimes on a test I'll give you a picture, but sometimes I won't. So you want to make sure that you label that correctly. I do want to have a little quiz tomorrow. Like I said, it's 20 points, which means I think there are 16 questions that are just 1 point apiece. All right, this is for 8 homework, all right? There are 16 questions. 8 of them are just stuff you should know. Sine of pi thirds, cosine of 7 pi 6, right? Unit circle. If you know your unit circle, it's just finding the values. So that's 8 questions. Then, so that's like these two together. This is from 4-7. There are also 8 questions using the inverse trig. Remember, they have restricted domains and ranges. So if I ask you to find inverse sine or inverse tangent, remember, you can only give me answers between negative pi halves and pi halves. So you can't give me an answer of like 2 pi thirds or 7 pi fourths, right? Like they can only be between there. And for inverse cosine, remember that it's from 0 to pi. It's just right or wrong. So you get it wrong, it's wrong. Like there's no partial credit. 16 questions from the 8 from the unit circle, 8 from inverse trig, right or wrong. Know your values. Then there are 2 graphs. Basic trig function graphs, 2 points apiece. We haven't done graphs in a while, but our test is going to have graphs on it, so I wanted you to look over them tonight. It won't be anything crazy. There will not be a period change in terms, like if I give you sine and cosine, the most I would do would maybe change the amplitude in front where I stretch it or shrink it. Tangents, cotangent, secant, cosecant. Look over how to find those asymptotes, because remember, if you can find the asymptotes for tangent, it's just like the S shape, and cotangent is just the other way. And for secant and cosecant, if you can find the asymptotes, you just draw those parabolas in there. 2 graphs that will be on your test tomorrow. That's 4 points of the 20 points. It's a 20-point quiz. I will still give you a chapter review assignment tomorrow because the quiz is not supposed to take long, right? Like it's kind of like one of those know your values, give me the answer. So I'll still give you your chapter review tomorrow, and then Friday the chapter review will be due, and we'll go over it, and then we'll have 2-part test. 1 day without a calculator, 1 day with a calculator. Okay? If you're behind on homework, all of your Chapter 4 homework will be due next week. So that gives you stuff to work on. All right? So 4-8 homework tonight still, but I just want you to know that we're going to have a little quiz tomorrow. It's one-sided only, so study your unit circle. Practice it.